Hi everyone, this is Mohammad Rizwan, faculty for Geography at Vajiram and Ravi. Today we are going to discuss an important topic of geomorphology, that is about surface configuration of Earth. So this is about understanding how is the landform getting configured on the surface of the Earth. See, there are primarily two dimensions we look at when we study Earth. One is the interior of the Earth. So in interior, we are studying about what is layering of Earth's interior. That is, we understand the type of boundaries, the material structure, composition in interior of the Earth. So we get to know about layers like lithosphere, asthenosphere, then lower mantle, outer core and inner core, and the concept of sial, sima and knife. The other important dimension in geomorphology is understanding about what lies on the surface. This is about knowing what led to the arrangement of the continents and oceans, why the fold mountains are located in the way they are, like why Rockies and Andes mountains are extending from north to south on the western margins of North America and South America, and why Himalayas and Alps are arranged in east-west. So, the surface configuration was focused as early as 1850s, and there was an established paradigm which was challenged by some of the geologists. So before 1850s, people believed, the scientist community as well as the geologists and geographers, they were having a belief that there is a permanency on the surface of the Earth. Permanency in the sense that whatever we see today has been existing from the beginning of the Earth. And this school of permanency was challenged, and there was a theory, that is concept of continental drift. Continental drift was published in 1912, and this was given by Alfred Wegener. So we are studying about the topic here. This is surface configuration of Earth, and this topic is important for both prelims and mains. So the first concept in surface configuration of the Earth is the theory of continental drift. This theory challenged the permanency school, and it gave that the surface of the Earth is dynamic, the continents are not static, the continents are moving, and this movement of the continent is known as drifting. And this theory was based on the concept of sial and sima and the idea of supercontinent. So what is a supercontinent? The theory proposed that 250 to 300 million years before present, if you go back in the geological history of Earth, the surface of the Earth was having a single supercontinent, that is Pangaea, and this Pangaea got disintegrated. So there was one continent, that is Pangaea, and this got disintegrated, and the segments of these Pangaea, they moved away from each other, and that led to the present arrangement of the continent. So this was the first theory. Now this theory came with certain drawback, limitation. This led to the second concept. This was the concept of sea floor spreading. So the theory of sea floor spreading was published in 1962, and this was given by Harry Hess. So the focus of Hess was on the ocean floor. He was a marine geologist, and Hess suggested that the ocean floor is more dynamic then the continent, and the ocean floors are continuously undergoing change, and because of spreading of ocean floor there is a drifting of continent. So continents are not independent entities, they are connected with the ocean floor. If the ocean floor is spreading, this spreading of ocean floor itself will result in the drifting of the continent. So this was the second idea, but this also was with certain limitation. So later on, that is, it was in 1967, the geologist Tuzo Wilson, who gave the concept of mantle plume. So what is a mantle plume? This is a rising thermal convective current from interior of the earth, particularly the mantle layer of the earth. And next was Jason Morgan, and he gave the theory of plate tectonics. So this plate tectonic theory is considered as most scientific explanation to the previous two theories. So we can understand this in this way, that we were having some idea about continental drift, but it was not very logical or scientific. Similarly, there was sea floor spreading, but this also could not justify the formation of the ocean floor. Thus, the scientific explanation of continental drift and sea floor spreading is provided by the theory of plate tectonic, and this theory was published in 1967, and this is proving the previous theory. So today if you want to write the answer, so there are themes of continental drift, there is a theme of seafloor spreading also, but if you want to write the answer related to the surface configuration of the earth in mains, you have to take the help of the plate tectonics. Plate tectonic is considered as the most scientific and valid explanation for the surface configuration of the earth. And it is not only restricted to the first order landform. Plate tectonic is explaining other features also, like it explains the formation of fold mountains, then it also explains the arrangement and distribution of island archipelagos. It also explains the distribution of the geophysical phenomenon. So what is a geophysical phenomenon? Like how are earthquakes distributed on the surface of the earth? Why there is a zonal pattern of distribution of earthquake? Similarly, how is the distribution of volcanism? Why the intensity of volcanoes differ from one region to other? This explanation is provided by plate tectonic. Even we can understand the distribution of tsunamis. Why certain regions of the world are known for occurrence of tsunami. This can be explained with the help of plate tectonics. That is why plate tectonic theory is considered as a comprehensive explanation of the surface configuration of earth. So when you are studying about the plate tectonics, it means that the theme of continental drift and theme of seafloor spreading is subsumed. It is merged, integrated with the plate tectonic theory. So when you write the answer, you have to see that you explain these things with the help of interaction of the plates. Now, this theory of plate tectonics is based on the modern view of interior of earth. So what is a modern view of interior of the earth? That outermost layer of the earth is solid, and this is known as lithosphere. So lithosphere is the outermost layer, and this lithosphere is placed over a semi-solid layer. So this is a part of upper mantle. This is known as asthenosphere. So how is the nature of asthenosphere? Asthenosphere is semi-solid. The temperatures of asthenosphere are very high. The material is in molten state, and because of this, the magma, this molten material, now starts moving towards the surface and it gets circulated like this. So this is also another magma rising and then getting circulated. Thus there is establishment of a convective cell. Convective cell, these are known as the mantle plume. So this rising current or rising material from interior, that is particularly the upper mantle, this is known as a mantle plume, and this mantle plume will cause the movement of lithosphere. So in this way, what is happening to the lithosphere? The lithosphere is getting divided. So we get a segment of lithosphere, and each segment of lithosphere now is referred as plate. So we get the term, what is a plate? Plate is a segment of a lithosphere. So lithosphere, the outermost solid layer of the earth is known as lithosphere. Lithosphere is floating on asthenosphere or upper mantle. The mantle plume is going to cause the movement. So we can say that below, this is a lithosphere, and below the lithosphere there are like conveyor belt like phenomenon, conveyor belt like structures operating below the lithosphere, and this will cause the movement of this plate. And when these plates are moving, they will interact with each other, and this interaction is referred as tectonics. So we get the term plate tectonics. And what is the source of energy for the plate tectonics? Is the mantle plume. This is the convections operating in mantle. Now, when the two plates are interacting, when they are moving, this interaction of the plate can be studied in the form of three types of boundaries. So, here we will simplify it as, suppose this is one plate and this plate is, these two plates are moving towards each other. So, here is a boundary. This will be referred as convergent boundary, or this is known as destructive boundary. So when the two plates are interacting in this way, one plate is going to subduct. This is the subduction of the plate, and the subducting plate will enter into asthenosphere and it will melt. So what happens here? The crust is destroyed. Thus, this type of boundary is known as destructive. So when you show it on the map, you can show it like this. So this will be a line with a triangle. I am just covering the basic part here. So what is a plate boundary? Plate boundaries are of three types depending on movement of the plate, that is convergent, divergent and transform. In convergent, there is a subduction. Subduction means downward movement and the plate falls into the asthenosphere. This will result in destruction of the crust. Therefore, convergent is known as destructive. When the two plates are moving away from each other, in such cases, the new crust will be created by the rise of magma. So, the divergent boundaries, these are divergent boundaries. and in case of divergent boundaries, there will be formation of the crust, thus they are considered as constructive plate boundaries. So the landforms that are created at convergent and the landform that are created at the divergent will be different. And the third type of boundary here will be when the two plates are moving parallel to each other. This is referred as transform, or this is conservative plate boundaries. So in this way, we have three types of plate boundaries: convergent, divergent and transform. Depending on the location of the boundary, we will have different type of interaction. This will result in different type of landforms and also different geophysical phenomenon. So this study of interaction of the plate is the major theme of plate tectonic theory. So we can classify, suppose you are looking at the world map, we can classify the plates into two, that is major plate and minor plate. So here I can show it as through the map, like this is on so here is so this is the world map and we can identify the plates. So this is a lithosphere. This is on the surface of the, so what we are doing here, we will consider the divisions. So this is a plate boundary. So this plate boundary is in this way. So there are two plates here. This one is North American plate, which has entire North America and part of Atlantic Ocean. So it is both continental as well as oceanic plate. It has a part of the plate is continent and part of the plate is oceanic. This one is South American plate, which is again part is continent, part is ocean. Then this plate is known as African plate. So what is happening in African plate? It is again a continental and oceanic plate. Now moving towards the interior, here this will be like this. This is now known as Indo-Australian. So these are the basic plates, right? 7 major plates we are identifying. Now today we can find that this is further divided like Indian plate and Australian plate. So some of the modern literature of plate tectonic, this will be showing further division of the plate. But when the theory was given, this was the 7 major plate identified. So this is African, this one is the Eurasian plate, and this is here is the Pacific plate. Here also is the Pacific plate. This one is Antarctic plate in this way. So these are the 7 major plates. Now in between we can identify some of the minor plates, like here interacting with the North American plate. This is known as Caribbean. Then here this one is the Cocos plate. Here attached to the South America is the Nazca plate. Then here this one is the Arabian plate. Then towards Southeast Asia we can identify this as the Philippines plate, and then this one is your Burmese plate. So this is the map of plates and plate boundaries, or we can say this is the map of a plate tectonics. So wherein we have divided the world map into major and minor plate, and depending on the interaction of this plate, movement of this plate, there will be arrangement of the landform. So the detail about how these landforms are created and how this geophysical phenomenon get organized, this we will be discussing in class. So this will be the major topic of geomorphology, and it is important for both prelims as well as mains exam. Thank you.